Hello and welcome to session 12 of our exam bootcamp sessions. Today we are looking at the binomial theorem, and this is not for AISL. So if you are in AISL, then you do not need to know about this. So this is just for AA. AA only. All right, so if you are joining for the first time, I'm Ashley from Miss IB Maths. I'm an IB teacher, tutor, and IB examiner. I offer private tutoring here if you're interested, and if you have any questions at all, feel free to message me on my Instagram, where I can answer questions or give you feedback on what you have. I'm happy to help. I know that this time can be quite stressful, and sometimes you just need someone to give you an answer or to explain something. So feel free to reach out there. And I'm collaborating with Exam Dojo for these exam bootcamp sessions. So we have all of the past sessions are on the playlist, so you can still watch them back. We have a couple more sessions to come, so keep an eye out on the calendar. And yeah, we have one later today on integration, and that will be for AA and AI as well. Yeah, let's get into it. We'll start with a little warm-up question, then we'll go through a little bit of just an intro to binomial theorem, and then we'll do some exam past paper questions, which is where it gets a bit trickier. So I think binomial theorem, not that challenging, expanding, fine, but the exam questions, they always ramp it up a little bit and present it to you in a more interesting way. So it's not just expand. I think if you get a simple expand this binomial theorem question, you're quite lucky. But they don't tend to do that. So it's mostly something else that you'll have to figure out within there. But I'm going to show you how you do that. So on your own, sorry, goodbye. Apologies for that. I suppose they're AI. Can you please draw Pascal's triangle until n equals 4? So obviously you can't put that in the chat, but on your own, grab a pen, grab paper, grab your calculator so you can follow along and try these things. And try Pascal's triangle for n equals 4. And the sounds in the background are my dog, in case you hear anything strange. All right, so Pascal's triangle is going to be really helpful to us in solving these binomial expansion questions. Without Pascal's triangle, things would take a long time. So there are other methods which we'll look at, but Pascal's triangle, if we have n equals like from 1 to n equals, I would say maybe 6, then Pascal's triangle is what you should use for an expansion. If it's anything more than 6, then that just is going to take too long. So then it's better to use the combinations formula, this one, which we'll look at later, so don't worry about that. But Pascal's triangle, we start with 1 on the top. So always a 1, and you have your little triangle of 3 ones. That's always important to get started. A lot of students forget that step. Then we add the 2 things above, and 1s follow all the way down the side. Add the 2 things above, add the 2 things above. And we can keep going down like this. Always 1s on the side. Add the 2 things above. Add the 2 things above. We can keep going. So let's see, this is the triangle. This is the 0th row. That's n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. You get that right? 1, 0, 1, 2, 3, 4, 5. And yeah, you can just keep going. So you can get all the rows. But obviously, if you don't have a lot of time, then you've got to stop at some point. So it depends on the question, but they're mostly going to be asking you around between like n equals 0 and n equals 6. that's kind of a good amount to, it takes very little time to put up that triangle. So as soon as you have that triangle and you have something like, let's say, x plus 2 to the power of 6, then you know, okay, I need to go to my 6th row, and these will be all of my coefficients here. Ooh, there they are. So you don't have to use this formula, which only produces one at a time. So you'd have to do this formula 1, 2, 3, 4, 5, maybe 6 or 7 times, because you might not know the n equals 6, choose 1. So that formula, doing it that many times, takes quite some time. And I think the triangle is way quicker. But obviously, if it's something like, I don't know, x plus 2 to the power of 20, then don't do Pascal's triangle. That's going to take ages and be a waste of time. Then I'd rather do these. But they are not going to ask you a question like that in the exam, because it would just be a waste of everyone's time. So it's most likely going to be somewhere in here. You often don't go further than that. All right, so that is Pascal's triangle. And how does that actually help us? Well, it gives us the coefficients for our expansions. So here you can see we have, if we expand a plus b to the power of 0, well, that's just 1. So like in our triangle, we had 1 up at the top there. Then a plus b to the power of 1, if we expand, we get 1, and 1 is our coefficient. So that was in our triangle, the next 1, 1. If you forget how to start the triangle, you can just do it like this. You can expand your own one to make your triangle. And then 1, 2, 1 for the second row. Always remember we start at the 0th row. A lot of people forget that, and they start from n equals 1 up here, and then you'll be completely off. So remember, it starts with n equals 0. Very important. Then we have 1, 3, 1. Crazy how maths do that. How cool. So that's why the Pascal's triangle is helpful for us in binomial theorem, because it gives us our coefficients that we need. But yeah, we do also have the formula. So in general, we have that the binomial theorem has this formula. If you have any two terms, bi meaning two, bi and nomial meaning terms, so two terms, that's the first term, that's the second term. If you have two terms and you have it raised to the power of n, then to expand it, you take the sum of all of those. So this just means the sum of all of them, because we add them all up. With n choose r, which can also be written like this. So we have n choose r, or n choose r, or n choose r. They're all the same thing. That gives us our coefficients. And then we take the first term a, n minus r, and the second term b with just r. So this is our formula, what we're doing. And like I said, we had the different way of saying this for n choose r, and that is the formula. And the great thing about that is it's given in your formula booklet. So I have here for SL, this is what you need, and we're just going to be focusing on this today, the combinations formula to give you your coefficients. And then this is the general formula. So it's saying I'm adding up all of those terms. Now, this formula isn't necessarily that helpful to us, but what I will say is helpful is this part here. This is the general term. So if you're not asked to find a whole expansion, if you just need to find one term, like they say, find the constant term, find the term in x squared, this is the formula that you want to use to draw that up. So if you need to find just one term, do not go and expand the whole thing. Sorry, I'm having an allergies, hay fever attack. So apologies for that. If you need to find just one term, don't expand the whole thing just to find that one term. That's way too time consuming. We're going to be focusing on this formula right here. So it's hidden in there, but you could just highlight it at the beginning of your exam and then come back to that when you need to use it. And we'll do a lot of practice with that. If you're in high level, you also have permutations formula, not involved in binomial theorem. And then you have the extension of binomial theorem, which is to have it to an rational number. So a plus b to the power of a half, for example. And that is a different topic. If you need help with that, let me know. But we won't work on that today. So, for example, let's see, if we want to calculate our coefficients, we need to be able to know how to calculate coefficients. Oop, not that one, that one. So 5 choose 2. That means my n equals 5. So I'm in the fifth row, and r equals 2. So let's do that using my Pascal's triangle. I need the fifth row. So here we go down to the fourth row. So let me just add in the fifth row. 1, 5, 10, 10, 5, 1. So that's n equals 5. Okay, great. We're in the fifth row. And then I need the second number. So maybe I'll use a different color. Again, we're starting at r equals 0. So that's r equals 0, r equals 1, r equals 2. So it should give me 10. If I calculate that using Pascal's triangle, then, no, not that one. Then 5 choose 2 is 10, according to my triangle. Now let's do it with the formula. So 5 choose 2 equals, so we have n factorial, which is, my n was 5 factorial, but r factorial, so that's 2. Then n minus r, that's 5 minus 2, which is 3 factorial. And now we need to solve this. So 5 factorial means 5 times 4 times 3 times 2 times 1. And 2 factorial is just 2, because it's 2 times 1. I recommend learning up to 5 factorial. So if you have 5, 4, 3, this just saves you a lot of time in exams. Any idea what 0 factorial is? Any guesses? So let's go from here. 1 factorial is just 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2, which is 6. So you can see we times by 2, we times by 3, so we times by 4. So 24 times by 4, 120. So each time here you can say we're dividing by, so here, 2 to get to 1, 2 divided by, what was I doing now? I have to divide by 2 to get to 1. I have to divide by 3 to get to 2. I have to divide by 4 to get to 6. I have to divide by 5. So can you see 5, 4, 3, 2? So in principle, that would then be 1. 1 divided by 1, which gives us 1. So 0 factorial is actually 1. A lot of people would think 0 factorial is 0, but 0 factorial is 1. And 1 factorial is 1. So each time we're just dividing by the number before it. So these are good ones to just memorize and have those in your head. So we have 3 factorial was 6. We had that from there. But another way we can simplify this sometimes is to write it out. This helps. Right now it's okay, but in bigger numbers, that was 2 times. Then 3 factorial is 3 times 2 times 1. So often I can just cancel out on top the same that I have on the bottom. So in these kind of numbers, it's not that big of a deal because they're quite low numbers, but in general, that can be a nice way to simplify those big numbers. So 5 times 4 is 20, divided by 2 is 10, and let's double check. Yep, we got 10, same thing. So you can use either one, Pascal's triangle or the n choose r formula, which is given to you in your formula booklet. Either one will work. You've just got to decide which one is maybe faster. Okay. So let's do an actual expansion. So we want 2x plus 1 to the power of 3. So let's lay out a couple of things here. It's in the form a plus b to the power of n. So my a term is 2x. My b term is 1. My n term is 3. So in Pascal's triangle, I'm going to choose that one because I think that's the fastest in this case. I have my 0th row, n equals 0, n equals 1, n equals 2, n equals 3. So these are my coefficients. Can you see that we always have one more term than the n we're given? So here it's n equals 3. So we're going to have 1, 2, 3, 4 terms. N equals 2, we're going to have 3 terms. So there's always one more term than the n. Sometimes they ask that question. If you have any questions or if I go too fast, let me know. So now I know that those are my coefficients. So I'm going to start by writing my coefficient of 1. Let me just put in brackets so it's clear. So we start with 1. Then we write 2x, and we're going to take to the power of 3. And my other term, my b, my 1, to the power of 0. So we start with the first term, a, going 3, 2, 1, 0, and the b term going the other way, 0, 1, 2, 3. So this one has 3, this one has 0. We've got to always make sure that these two powers add up to our n, whatever our exponent is. Okay, and we add. Our next coefficient is 3. Then we take 2x again, my a term, and now we had to the power of 3 here, so now it's to the power of 2, because we're going down. And this one was 0, and we're going up, so it's to the power of 1. And we check 2 and 1, good, they still add up to 3. Then I'm going to come down here. My next coefficient is 3. 2x to the power of 3, 2, 1. And 1 to the power of 0, 1, 2. And then my last term with a coefficient of 1. 2x to the power of 3, 2, 1, 0. And my 1, 0, 1, 2, 3. So at all times, these add up to 3. Great, so that's my 4 terms. Now I simplify. Well, 1 to the power of 0 is just 1, and that's 1. 2x to the power of 3 is 8x cubed. Now, again, a lot of people I see doing that, saying 2x to the power of 3. But if there's a bracket here, that means the 2 also gets the 3. So it's 2 to the power of 3, x to the power of 3. So be very careful with that when there is a number in there in the brackets and when you have negatives especially. So we have 8x cubed. Now here, 1 to the power of, this one term is always going to be 1, so we can ignore it. 2x squared is going to be 4x squared times 3 is 12x squared. Not that one. Then we have here 6x. Just there. And here it's to the power of 0. So that whole term is going to be 1. So it's just plus 1. 1 times 1 times 1. And here you can see our powers go 3, 2, 1, 0. And there we have expanded using binomial theorem. All right, let's do, maybe we do this one quickly with negatives just to show you how it works. So I'm going to go through this one a little bit faster. We need the 4th row, so let's go and steal that from where we have it up here. 1, 4, 6, 4, 1. So in our 4th row, n equals 4, we have 1, 4, 6, 4, 1. So those are my coefficients. And I need to go with, so we're going to have my coefficient of 1. Then my b is going to be to the power of 4. And my minus 3 to the power of 0. Then we take coefficient of 4. B is to the power of 3. And minus 3 in brackets because it's negative. We need to take that negative. Be very careful. That is 1. Plus 6. That looks like a B. That should be a 6. 6. B, 4, 3, 2. Minus 3, 2, always adding up to 4, plus 4, b, where were we at? 4, 3, 2, 1, minus 3 is now to the power of 3. And our last term, 1, b to the power of 0, and minus 3 to the power of 4. So let's double check. 0, 1, 2, 3, 4. Okay, and for my b's, 4, 3, 2, 1, 0. Great. And now we simplify. So minus 3 to the power of 0, just 1, so b4. Then minus 3 times 4 is minus 12. When you have a negative, you're going to get these oscillating, we call it signs. It's going to go plus, minus, plus, minus. B3. Then we have minus 3 squared is positive 9. So 9 times 6 is 54. B squared. See how it's going negative, positive. Then we have minus 3 to the power of 3. So that is minus 27. So that's going to be minus 27 times 4. 27 times 4, that's going to be 80 plus 28. So we have 108 minus 108b. Oh, no, did I? Yeah, 27, I said. See how it goes minus, plus, minus. And then we have b0, so that's 1. Minus 3 to the power 4, because it's a positive exponent, not a positive, an even exponent, it's going to be a positive number. 4 negatives make a positive, and that is going to be positive 81. All right, so just be careful with those negatives there when you have your brackets. So make sure when there's a negative in there, it goes negative, positive, negative, positive. That was from earlier. So, yes, I wanted to draw your attention back to the general term. So that's what we were talking about earlier, this one, which is hidden in there. If you're not asked to do the whole expansion, if you're just asked to find a term, a general term. So in this question, they want us to find the coefficient of the x cubed term. So in my expansion, I'm going to get something, something, plus something, something, plus whatever the coefficient is, let's call it a, x cubed plus da, da, da. Okay, so they want to know, what is that a? What is that a? And I'm going to just focus on this term, the x cubed term. I'm going to ignore everything else. I'm not going to expand everything to find it. I'm just going to work on that. So I use the general term formula, which is n choose r, a n minus r, b r. So again, that is hiding in there when you need it. So let's set this up with what we know. We know that n is 6. And this is how I recommend you approach every single problem where you need a term. Just set up with what you have first. So n is 6. We don't know what r is. R is always going to be the thing that we're going to need to figure out from the question. Everything else is standard, is given, we just put it in. But r is the thing that we need to think a little bit about. So my a term was 1, my b term was 2x. So n was 6, we still don't know r, and b is 2x, we still don't know r. So we filled in everything that we do know. And it will always look like this because there'll always be an r that we need to figure out. So all of this needs to equal my term ax cubed. Remember, we don't know what the coefficient is. We don't know what it's going to be. And it's not just this value, because this 2 is going to produce a number as well that's going to work with that to give us the full a value. So it's not just the n choose r value. Okay, so I need to figure out what value of r here is going to end up with giving me an x cubed. So I look at the value, the x term. That x over there, what value of r here is going to give me an x cubed? And in this case, it's quite clear. R has to be 3, because if I have x to the power of 3, it's going to give me my x to the power of 3 term. There's no other x around here that's going to affect that. So R must be 3. And that's usually always the biggest hurdle that you've got to get through, is just to figure out what R is by setting it up. And it's not always clear, but if you set it up like this, you can quite clearly see what it is. If anything of this is making absolutely no sense to you, please let me know. So now let's fill in my r value. 6 choose 3. Just substitute everything in. 6 minus 3 is 3. 2x3. And all of that is needing to equal my x cubed term. We're trying to find a, the coefficient. I should say that I was calling that capital A, not this a. Okay, so 6 choose 3. Let me cheat and go back to where I had my 6 column. Or no, let's use the formula, because it's good to use the formula. Let me do my other working on the side. 6 choose 3 is, I won't be lazy. So 6 factorial over 3 factorial, and then 6 minus 3 factorial is another 3 factorial. So 6 times 5 times 4 times 3 times 2 times 1. 3 factorial, 3 times 2 times 1, and we do that twice. I'm writing out the full thing, but maybe by now you don't need to do that. You can just see. So 3 times 2 times 1 can cancel with that 3 times 2 times 1. So this is just 6 times 5, which is 30, times 4, which is 120, and 3 times 2 is 6, 120 divided by 6. So there, all of a sudden, it's a lot less multiplying. So that gives us 20. All right, so our term here, our 6 choose 3 is 20. 1 to the power of 3 is just 1. I'll write that in anyway. 2x to the power of 3 is 8x cubed. All right, and now I've substituted. So remember, I'm trying to find my a term. I have 20 times 8. So that's 160 x cubed equals a x cubed. So can you tell what is the coefficient? It's 160. There we go. I could have dropped this x cubed earlier on in the working, but just wanted to make it clear. So there we go. That's an example of how you can use it. So always use the general formula, which, just to remind you, is hiding in there. All right, another kind of question. Find the constant term. So here we wanted to find the term in x cubed. Now we want to find the constant term. Well, the constant term just has, this is an important thing to know because they often assume that you're going to know this. They say the constant term, but what they mean is the term that has x to the power of 0, because x to the power of 0 is 1, so there'll be no x. So the constant term, they want the ax to the power of 0. So let's go ahead and set it all up again. So let me just write it. N choose r, a n minus r, b r. This is my a, this is my b, and n equals 6. So in n equals 6, we want to have 6 choose. We don't know what r is yet. It's not just necessarily 0. It's probably not 0. A was x, 6 minus r, and b is 2 over x, r. And we want to know, when does this equal ax to the 0? So let's have a look at this. Right, if I think about my 6 choose r, that's just going to give me a number. We're trying to find what value of r is going to give us to the power of 0. So we're only interested in the x's for now. What values are going to give us x to the 0? So what I'm going to do is I'm actually going to ignore any terms. Let me just cross them out for now. I'm going to ignore any terms that are not to do with x. I'm just interested in the numbers now. So let me write that here. It's x. I don't want to cover it. Let me do it a bit higher. This is just my side working. So I have x, 6 to the minus r. That's a term that's going to be involved with my x to the 0. Numbers don't help. This is 1 over x r. So I'm just going to write that as x to the minus r for now. That's times. The 2 I'm not bothered with for now because that's just a number. Has got to give me a term of x to the 0. So if I have exponents with the same base, I can add the exponents. So x 6 minus r plus minus r equals x to the 0. And now they're all over the same base, so I can drop the bases and just solve up here. So 6 minus 2r equals 0. So I just need to go and solve that. Sorry if I've cut it off on the screen. So r equals 3. Let me just move that aside there. So now that was just to help me figure out what r was, to give me an x to the power of 0. So I didn't care about any of the things that are going to give me a number. I just wanted to know what's going to influence my x's. And then I can set up an equation and be able to figure out that value of r. So now that I know that value of r, let me go and write this again. 6r3 And then we have x. 6 minus 3 is 3. See how that's giving me an x to the power of 3? But this over here is going to give me a value that will cancel out. 2 over x to the power of 3 should give me my ax0 term. All right, so 6 choose 3. Did I calculate this already? I did. In the previous example, I had 6 choose 3, which was 20. So I know that that's 20. x3, 2 to the power of 3 is 8. X to the power of 3, so that's important there, equals ax0. So now you can see my x3's cancel out, which is what we wanted. So 20 times, that's 160 equals ax0. So my constant term a equals 160. And done. So you might have seen that because we need to cancel these out to get the constant term, that would need to be x to the power of 3 and that would need to be x to the power of 3 and then they cancel. You might have seen that, so you don't need to set up this whole situation. But there are many times when it isn't clear to see what value of r you need to do. So I just find, no, didn't need to take that away. I find that setting it up in this equation is the best way to be really clear and to not have to think too much. Okay. Everyone still fine? Making sense? So, another kind of question. Given the coefficient of x squared in this binomial is 80, find a. So they're saying the coefficient of x squared is 80. So our term that we're interested in is 80x squared. That's the term we're resulting in, 80x squared. This is what we want to know. So when we're setting up our term, we want to find the coefficient. We've been given the coefficient. We want to find the value of a here. So let's not freak out because we don't know what that a value is. Let's just do everything that we would do normally and just ignore the fact that we don't know what a is. So just follow the method, and that's generally the case with everything. Just do the method and you'll see that it will come right. So let's go fill all of this in. So here's our formula. We know that n is 5. Choose, we don't know what r is yet, as usual. A is 2. This was our a term and our b term. So that's 5 minus r. B is ax and r. And that should all give us 80x squared. That's what we're trying to find. So if I have a look now, I want to end up with x squared. So where's my x term? Here's my x term. So what value of r is going to help me to have x squared? Well, just r equals 2. So when it's written like this, it becomes really clear what you need. R equals 2. So let's go ahead and fill that in with r. Nope, I want this one. 5, choose 2. 2 to the power of 5 minus 2 is 3. Ax to the power of 2. Actually, I might just write this whole thing out. Ax squared a squared x squared to multiply out that 2 equals 80x squared. For now, I'm just going to cancel out my x squareds because I have one on both sides. 5 choose 2. Well, we can use, again, Pascal's triangle because it's only 5 rows. We can also use our formula of n choose r, but I'm also just going to show you how to do it on the calculator. So probability combinations, and then you get n choose r, and we want 5 choose 2. 5 choose 2. So if you have your calculator, that's another way you can do it. That's 10. 2 to the power of 3 is 8. A squared equals 80. Remember, we're trying to find a. See how it's just happened. We didn't even do anything. We just kept going with our usual formula with substituting in, and we're just ending up finding our a without even trying. 80a squared equals 80. Divide by 80 on both sides, we have a squared equals 1. So a equals, what does a equal? I hope you said positive or a negative 1 as well. They didn't say anything about what a could be. They didn't mention if it was positive or negative. They might have given a condition in the exam saying a must be more than 0, but now they haven't. So a is positive or negative 1. Okay, I think I'm going to skip this question for now because we've done a few of them and there'll be some exam questions like that. I would like to get on to the exam questions. Something about them just always looks scarier, doesn't it? But it's the same. We follow our method. Find the coefficient of x6. 4 marks. This is a paper 2, so we have a calculator. That's great. This is a lovely, easy 4-mark question. Find the coefficient. So again, we're wanting to find the ax to the power of 6. We want to find the number in front. So we're looking for a single term, not a full expansion. So we're not going to fully expand, also because it's to the power of 9. It's going to take forever. So we need our formula for just one term. All right, let's fill in what we have as usual. That was my a, that was my b, n is 9. 9, choose r. Don't know what r is yet, doesn't matter. A is 2x. Use brackets with that 2, please. 9 minus r. B was minus 5. Do not forget the minus 5 to the power of r equals a x 6. Now, to find my value of r, I need to have a look. What value here is going to give me x to the power of 6? And it's 9 minus r. So I need a 9 minus r value that's going to give me 6. So that means r must be 3. If r is 3, I have 9 minus 3, which gives me x to the power of 6. So r equals 3. So 9, choose 3. 2x to the power of 6, that's what we wanted all along. Minus 5 to the power of 3, r is 3, equals our ax6 term. Thank goodness we have the calculator because I do not feel like calculating 9, choose 3. So let's do it again. So we have our calculator. 9, choose 3. 84. And we have 2 to the power of 6 is 64x to the power of 6. Minus 5 to the power of 3. Well, 5 to the power of 2 is 25. So 25 times 5 again is 125. And it's minus, and this is an odd number. So our answer is negative. Negative 125 to the power of, oh no, not to the power of 3. We already did that. Minus 125 equals ax6. All right, now we have an x6 on both sides, so we can drop it because we're just interested in finding the coefficient. So 84 times 64 times 125, I'm definitely not going to do that myself. 84 times 64 times minus 125 minus, no ways. The amount of times we get 6, 7. Minus 6, 7, 2000. And how nice, this already is in 3 significant figures, but we weren't rounding anyway, so that doesn't actually matter. And there we go, the coefficient is that. So let's take a look at the mark scheme. Where are we getting those marks? So attempt to form a product of binomial coefficient, a power of 2x and a power of minus 5 seen. So that's just basically an attempt to set this up. If they see something like that, you get a mark. Even if it isn't correct, just for attempting to set it up, you get a mark. Then for your full correct one, you get 2 marks. So that's already 3 marks just for setting this up correctly. So you got 1 for attempting here, and then 2 for having these. And then the final answer of getting this. Pay attention that you don't get that final mark if you said x to the power of 6, because they asked specifically for the coefficient only. They only want the coefficient. So pay attention in the question. If you give this answer, that's not a coefficient, right? So you're showing that you do not recognize what a coefficient is. So you will get a 0. So you want to have just the number to get that final A1. All right. We kind of did a question like this before, so just in the interest of time, I might go on to the next one. This is very similar to the one where we had to find the A value because they give us the coefficient. So that would be 1, 3, 2, 0 in x7. You can put that together. You do your formula and you work backwards to find K. So I think I won't do that one for now. Like I said, they have this question, write down the number of terms in the expansion, and it's always your value of n plus 1. A lot of people just take the n to be the number of terms. The amount of times people will write 11, but it's actually 11 plus 1, so there's 12 terms. There's always one more than the value of n. That's an easy 1 mark question. All right, let's try. Do I do this one or this one? Which is a better one? Maybe we can do both. Okay. They're giving us some information with 2 missing variables, A and B, A and B. That immediately should alert you to a simultaneous system of equations. So we're going to get 2 sets of information here, and we're going to need to use them to solve for A and B. And a little caveat here, A and the value of B, where AB is positive. So again, like I always say, you should bring a highlighter into your exam. And when you're reading the question, highlight these things, because we're probably going to get 2 values of A or 2 values of B, and we need to only take the positive versions. So A and B are positive, that's what it's saying, or more than 0. They're positive only, and they're not equal to 0. So let's, as usual, just set up what we have. So don't be scared of the numbers. The coefficient of x6 is 448, so I can set up my n choose r. I can write it up here, a n minus r for you. Maybe I'll make this fancy and just put it into a box so we know it's a formula. Very fancy. Okay, let's set up my first one. I can even call this equation 1 and equation 2 to keep us not confused. So equation 1, we're going to do n is 8. Sorry, that's my dog. Choose r. A is ax cubed. Oh, there's a cubed in there, so brackets are important. 8 minus r. B is just b, that's nice, and r. Okay, so we've set up the first one, and that's equal to 448 x6. Okay, down here I'll do my second one, same thing, but now I have 10. 10, choose r of ax cubed. 10 minus r this time. That's a good 7 marks for this because there's quite a lot going on, but we're just using the formula. Nothing to panic about. And also B, R. Sorry. Don't know if anyone else is dying from allergies that time of year. Is equal to 2,880 x6. Okay, so we've set them up. Now we need to know what is our value of r. So in the first one, I need to get x6. So in order to get x6, well, I already have a 3 there. So 3 times what is going to give me 6, and it's 2. So I need to result in a 2 here. So 8 minus what gives me 2, and it's 6. So R is 6. So I can fill that in. 8, choose 6. AX3. 8 minus 6 is 2, which is what we wanted to give us 6 there. And B6. 4, 4, 8, X6. Okay. Might just bring this one down a little bit so I have some more space. So there. And now, what value of R do we need here? So again, we need x to the 6. So we have a 3 there, so this needs to be 2. So to get 2, we need 10 minus 8, so R is 8. See how clear it is to see what value of R we need when we've set it up like this? Or at least I hope it's clear. 10, choose 8. X to the power of 3 of 10 minus 8, which is 2. B, 8 equals 2880. X to the power of 6. Okay, now we can just start simplifying. 8, choose 6. Is this a calculator? Yes, we can use our calculator, thank goodness. So I'm going to write 8, choose 6. So bring that up again. 8, choose 6 is 28. Now let's multiply that out. A squared x6 b6. Is that correct? 4, 4, 8, x6. Okay, and this one, 10, choose 8. 45. 45, a squared x6 b8 is equal to 288. All right, so now we have our equation set up and we can start simplifying. So firstly, I'm going to get rid of my x6s on all of these. So I just have my terms in A and B. And I might actually just write them again down here. So my first equation is now 28a squared b6 equals 448. And my second one was 45a, not x, a squared b8. All right, so much simpler equations there now, just with A and B. 28 I can divide on the other side to just get rid of those terms. So 448 divided by 28. Again, my dog, not me. 16. And 45 we can divide on the other side. So 2880 divided by 45. Please give me a nice number. Yeah, 64 equals 64. Okay, when we have simultaneous equations with A and B, we can solve them by dividing one by the other. So if we have linear equations, then we subtract or add one equation to the other. But now I'm going to do equation 2 divided by equation 1. So equation 2 is this one. So I have a squared b8 divided by a squared b6. Remember, a and b are more than 0 and cannot be 0. And then we take 64 divided by 16. So we can cancel out there. b8 divided by b6 gives us b2 equals 64 divided by 16 is 4. How nice. So b equals plus minus 2. We square root each side, positive or negative 2. But they said, but B is more than 0. Remember, this came in useful. They said that at the beginning of our question. Remember, it's only positive. So B equals 2. Okay, now that we have B and B is 2, we need to figure out A. So let's choose any one of our equations. I'm going to pick this one. A squared B 6 equals 16. Now we know B is 2, so A squared 2 to the power of 6 equals 16. 2 to the power of 6 is 64. Let me do some brackets. So I have 16 divided by 64. And I need to root both sides. I have a calculator, but I might as well do it now. 64, both square numbers. So A is 4 over 8, which is a half. And remember, it's only positive. So I should technically say positive, negative, positive, negative. But so I show that I know that A is more than 0. Therefore, A equals a half. So A equals half and B equals 2. There we go. And we have solved everything. So that's also how it could be asked. In the mark scheme, we have, again, evidence of correct term chosen. So laying out your working product of a binomial coefficient. So using the formula to set it up like this. Your correct equations may include the powers of x. So I kept those in and only took them out at the last minute. And there we go. B equals 2 and A equals a half. If you did say that B was positive, negative 2 and A was plus minus a half, then you will not get all the marks. You will get 1, 2, 3, 4, 5, 6. Okay, so you'd only lose out on 1 mark for that. But these marks add up. So you could also attempt to solve your system graphically. That's also possible. All right. So I think I might stop there. If you want these questions, please just go to my Instagram at Miss IB Maths and send me a DM and just say, this is my email address. Can you please share the session notes with me? And I have a whole bunch of, at Miss IB Maths, all the session notes and past paper exam questions with mark scheme, like way more questions than I'm able to do in an hour. There's a whole folder that I've put together, so you can just DM me and send me your email address. So some exam tips and common mistakes. Like I've said, to put your terms in brackets. So if you have minus 2x, you must put that in brackets, like to the power of 3, because that's going to be minus 8x cubed. Whereas if you have minus 2x to the power of 2, that's going to be positive 4x squared. So that negative is affected by there, that number is affected, so please don't forget brackets. Don't confuse coefficient and term. Be very clear what the question is asking for you. Do they want the coefficient or do they want the full term? So when we were calculating earlier, we had something like 80x squared. That's the term, right? If they want the term, that's what they want with the x squared. If they say coefficient, they just want the number in front because that's what a coefficient is. Coefficient, then they just want 18. Yeah, don't forget that we start with n equals 0 and r equals 0 in Pascal's triangle. So when we have this, this is the row n equals 0 and this is the row equals 0. So that's very important to not forget. Yeah, and when you're starting it, it's always that 1, 1, 1 in the triangle. So make sure you remember that. There are a whole bunch of notes if you go to Exam Dojo and Learn. There's all the practice and assessments and question bank, but also Learn. And for each topic, there's a whole bunch of notes explaining it super well, going through each topic with all the formulas, with all the exam tips, with all the common mistakes, and with example questions, worked examples. So that's a really good resource. There will be a homework assignment if you'd like to do some more of these practice questions called Homework Session 12. Any questions at all? I hope you learned something new today and that it was made somehow clearer. But yeah, any questions? Just give a couple seconds in case anyone wants to type something. All right then. Thank you very much for joining, and all the best with your studying for exams. I hope that they're going well, and yeah, have a lovely rest of your day, and maybe see you later at the exam session on integration. Goodbye.